This is just for everyone. However, it is skipping the how to get to. This is just the equation that you need. I've broken it down without using the summation symbol to prevent any confusion for those who aren't familiar with it. We just pulled out the negative here to allow you to know that you have a heated print bed and the heat is going to be leaving it if there's colder air around it. So the temperature of the print bed, subtract the temperature of the air, divided by 1 over the average convective coefficient for a heat plate with cold air below it, which we found to be 1.79. So 1 over 1.79 plus these numbers right here are actually going to be the things that you decide based on the thickness that you have available to you, something that you can machine, fabricate, or you could find online, which would be the easiest for most people. And we have the conductive coefficient for various materials, and the smaller the better. You can find these values online for various materials, and again, that this material choice that you choose will be something that has to be something available to you, otherwise what's the point in calculating it? We have calculated for 1 32nd inch of cork with adhesive backing and 1 32nd inch of Teflon, which we sandwiched together to put together for our insulation material. Now, make sure that your units match, because when you are calculating to get this final heat transfer, you can't have thickness in inches with the conductive coefficient of watts per meter Kelvin. That would not work out. You would get strange numbers, and I'm sure I'll get plenty of comments anyway about this. If you aren't concerned about using any other materials than whatever I've chosen, let's just move forward, and I will show you exactly what I did with the cork with adhesive backing and the Teflon. Let's get started. that's it, everyone. We've installed our composite layer insulator on our 3D printer heated print bed, and we've clamped it down using simple binder clips with the legs taken off in order to avoid any clearance issues with the mechanics beneath or the print bed itself when it moves. And that is actually a temporary fix. On the way, I have trim protectors or trim covers to cover up all the edges where any aluminum is exposed to minimize heat transfer in that direction as well. There's an opening on the corrugation pattern where the aluminum of the print bed is. I want to close it off to make sure that I don't have airflow going through, because I can actually see through directly to the other side of my print bed. And I don't want to be able to do that, because that means that airflow can get through there and it cools faster, especially since the corrugation is in the direction of the motion in the Y direction. So I will have trim protectors covering up all the sides with a 3/8 inch gap to clamp onto my 7/16 thick print bed now. The weight is insignificant, which is great. Cork and the Teflon are both very lightweight materials. And that's about it. So that's all I got for you guys. Please like if you actually enjoyed this video. Subscribe if you'd like to see more videos where I show you both the math, science, and I show you how to do what we're going to do in our videos. And comment if you have any questions, no matter how simple or complex they might be. I'll try to answer to the best of my abilities. Thank you very much for watching, and I look forward to seeing you guys in the future.
Watch me bust they shit. Okay.